Okay, so very first thing we got before we get into anything on this one, we're going to show you some log properties for these. And basically, we've got a certain set of properties. We actually get to use them two different ways. One way you're going to expand, one way you're going to condense. And it just depends on how the question is kind of written as you go through these. So, very first one we'll look at here, we're going to expand using the different properties, and then we'll use the same properties to then condense it back together for this one. So. Okay, so the first one is the product property. Okay, so for the product property, basically is this. All right, and if you expand it, basically for expansion, you go from having the word log written once to the word log being written maybe two, maybe three times, just depending on how many things you've got here in this case. So basically this one, if you've got log of m times n, if you've got two things together, to expand it, it makes it the log, and the base will stay the same, log of m, and then plus the log of n. Well, m and n is just two different numbers, so it could be, and then we'll show you an example of these here in just a second. So, okay, second property. If we got product, we're going to do quotient. So we're going to start off with log, again, still base b. This time we're going to do m divided by n. And if you expand that one, if multiplication becomes addition, division is going to become, there you go, it's going to be subtraction. It's going to be log of m minus log of n. Okay, and the third property, and there's only three that we're looking at. The third property, it's an expansion property, but you don't really rewrite it with more the word log written a couple of different times. It's just a different way to kind of do this one. This one's the power property. Okay, so it's still log of m, still base b in this case, but now you're going to have m to a power, so it's m to the p power. And if you have that one, you can rewrite it as p times the log of m. And again, b is still your base. And for that one, you can really think about that as being like in parentheses there almost. Okay, so that's the three properties for expansion. And here's what it's going to do. We're going to show you some examples of where they're going to give you, and they will tell you which way to go. So it's not one of those things of, what I do. They're going to tell you to expand, or when we look at going the other way, we're going to condense it. So you'll know exactly what it is that you're doing. So it's not going to be a trick question. Okay, so the directions will be expand the log expression. Sure. Okay. All right, so let's do log base 5 of a squared and b to the 7th. Okay, so when we expanded, actually you got a couple of things here, right? That you've got a squared times b, that basically you've got multiplication in the middle. So the very first thing you would have would be log base 5 of a squared, and then plus log base 5 of b to the 7th. So multiplication, because it's a squared times b to the 7th, so we'll take the multiplication, make it a plus. Bless you. Okay, and now you got the powers that's here, which kind of matches up with this one. So then you can take each one of these powers that's up here and then just bring that part out front. So you can bring the 2 out front and make it 2 times the log of a. And then 7 times the log of b. And in that case, you don't have to put the parentheses because it's kind of understood there. Sometimes if you've got multiple things like this, you may need parentheses possibly involved in. Bless you.
Dang, bless you. I've never seen something.
Okay, everybody okay with that one? Everybody? All right, let me give you one more expansion, and then we'll go back to condensing because I think most of the time, condensing is the one where you're going to do a little bit more than expanding when we're solving equations, which is kind of where we're getting ready to go here pretty soon. Wait, go back. Go. Okay. All right, so for B here, let's do log base 7 of, let's give you a bunch of stuff here. Let's do r to the third t over b. Okay, so you've got two main operations here, and we got kind of the third one with power. So you've got r to the third times t divided by v. So if you do this one, you just take it in order. We've got log base 7 of r to the third. Because of the multiplication here, that makes that a plus. Log base 7 of t. And then because of your fraction where you've got the division, that's going to turn that into a minus. Log base 7 of b. Again, the one thing that's always the same for any of these expansions that you do, whatever the base is here, it will stay the same as you move through everything. Okay, and then one last thing you can do, where you've got the power here with the 3, then you can take that 3 from out top, bring it out front, and make it log 3 times log of r, and then everything else behind it will just stay the same. All right, seems like it's pretty straightforward. Okay, so multiplication becomes addition, division becomes subtraction, and if you have a power, just take your power out and then bring it back out front there. Okay, so there's your 3 properties doing expansions. Condensation, when I ask you to condense, it's going to be the same thing. It's just now we're going to take it from something that looks like this, and you're going to bring it back so that it's got only one log expression written with it there. So now we're going to go in reverse. So we're going to condense. So when we go to condense it, we're going to reverse the order. That everything's going to go. It's the same properties. We're just going to bring it backwards. You know, instead of stretching it out, we're going to kind of bring it back together here. So, and again, when I ask you to condense it, that's where again you're going to rewrite it so you only have the word log written once. So again, if we're condensing this expression, we bring it back so it would look something like that. So it's just taking everything and doing expansion in reverse order. All right, so here we go. Let's do log of 5x plus log of 3. Okay, so again, if you've got plus in the middle, that meant that these two things had to be multiplied together. So we're just going to do 5x times 3. Well, that's just 15x. Okay, so for this one, let's do 6 times the log base 2 of x, and then minus 5 times the log base 2 of y. Okay, so very first thing you've got with this one is that it's kind of like still doing order of operations. You've got your exponents first. So before you can do the subtraction that's here, you've got to do your exponents, which again is the 6 that's out front. So first thing we're going to do is we're going to make that log of x to the 6th power, and then minus log of y to the 5th power. So taking our exponents back up to put them so they actually look like exponents. Now we've got the subtraction in the middle. And so subtraction means those two things have to be divided. So then we'll make it x to the 6th over y to the 5th. And somebody may be asking, what if we brought this thing back together? If we had it, as long as you can get back to x to the 6th and y to the 5th, that's the main thing. You could kind of maybe do a little different, get there. As long as you get back to that answer, that's what we're looking for. Okay, now some of the things is we're doing some of these, and this is where we're going to start kind of putting some of these things together. Is that some of these problems we've got that you actually, after you do some condensing on these, you might actually get an answer that's like a nice, easy answer to work with. So for this one, I'll show you this one here. So let's do 2 times the log of 6 base x, and then minus log of 9. All right, somebody may be thinking, will they ever give us one that's got different bases? No, because if you've got different bases, you cannot condense them, you cannot simplify them. They have to be the same bases before you can do that. I'm sure somebody out there was thinking that one. Okay, so similar to the one above it here. Again, we're going to bring the 2 up top, so we'll make it log of 6 squared minus log of 9. We've got 6 squared. You can make that 36, right? And then because of the minus in the middle, when you bring those two back together, that's 36 divided by 9. Oh, that's just 4. All right, now here's where we're going to do the one last example, and this is where we'll start to tie in your calculators with this last example. So we're going to go log base 4 of 32, and then plus log base 4 of 2. Okay, again, plus in the middle means we're going to multiply the 2 and the 32 together. Makes it 64. Okay, now here's where we're going to use, because again, this is the answer that in today's stuff that we're going through, they're going to say, all right, if you get to the end and your answer, you can simplify. You can simplify. Now, what we're going to do in this case is this is where we're going to show you 2 things. One, how they want you to kind of do this one, but then number 2, show you also how to use your calculator, because a lot of times they're going to ask you to rewrite these problems, but if you know how to use your calculator, in some cases, it's going to make the work a lot easier as you go through these. Okay, so if you got log of 64 base 4, this is not the actual answer. We'll show you what the answer is here in just a second. But what they're going to ask you to do for a lot of these cases is they're going to ask you to take this problem you've got here, this log base 4 64, is they're going to ask you to simplify that one. Now, they're going to tell you without a calculator. So we're going to show you how to do it without a calculator, but then we're also going to show you how to do it with a calculator. Okay, so when they ask you to do this without a calculator, here's what they're thinking. Here's what they want you to do. They want you to kind of take this problem you have, and this is kind of what you want to think. Is that you're trying to figure out what that equals. So you want to take that answer you got and you want to think, all right, what does this thing actually equal? So I've got log base 4 64. What does this thing actually equal? So go ahead and put an equals x here. They don't put that. And a lot of times that used to throw me off because they were like, solve this. And I was like, there's not an x there. So if they tell you to solve this thing, especially without a calculator, go ahead and think that whatever you've got equals x. And if you've got it here, here's what they want you to think of. Is that we're going to take this thing and rewrite it in exponential form. So if we can practice what we were doing yesterday. So if you take this thing and rewrite it in exponential form, we said this is where it gets pretty easy. You just take the word log off, and then you switch these two numbers. So we got 4 to the x equals 64. Okay, so 4 to what power equals 64? Because 4 to the first power is 4. 4 to the second power is 16. 4 to the third power is 64, right? Do 4 times 4 times 4. So in that case, so 4 to the third power is 64. So in that case, that means that x has to equal 3. So they ask you to take this thing and simplify it. Now again, they never gave us an x in this case. So if they ask you to simplify this one without a calculator, the answer would just be 3. Okay, so any of these problems that they give you and they tell you, okay, take this problem you got, think about what this answer is, simplify it without a calculator. That's the thought process that you want to do. That you want to take it from this to think of rewriting it so it's in the, written out like this, rewrite it in exponential form, and then we go from there. Let me show you a couple more of those, and then we'll show you how to use your calculator. Because after I show you how to use your calculator, you're going to be like, why did we ever do it this way? Because, again, it's a thought process they want you to kind of think about in this case. So that's example 1. I'll call this example 2 here. Let's go with this one. Log base 72 of 1. Okay, and again, for me, when they talk about doing this one, that if they ask you to do this, just think, okay, what does this thing equal? It equals x. And then once you've got it from here, again, then you get to rewrite it in exponential form. Okay, so if you rewrite it in exponential, it's 72 to the x power equals 1. So what's that power got to be in that case? There you go. I like it. Everybody's remembering that. So 72 to the 0 power equals 1, right? So in that case, that means x has to equal 0. So if they ask you to simplify this one, that thing's just 0. Yeah, so anytime you get log, so basically here's kind of the thing if you're doing this, and this is kind of what they want you to see off this question. Anytime you get log of 1, doesn't matter what the base is. If you ever get log of 1, this could be 72 or 2 or whatever, it's always just going to be 0. So if you ever get log of 1, your answer is always going to be 0, regardless of what the base is. What? Because no matter what you do, if it was log of 4,367 to the first power, it's still, if you think about that equal to x, it's still that number, which to the x power equals 1. Well, the only way to get 1 is it's always got to be to the 0 power. So no matter what the base is, this thing will always be 0. Whether it's 72, 4,367, whether it's 7 or 2 or whatever, if you've got log of 1, it's always going to be 0. So it doesn't matter what the base is going to be to get you there. Okay, now here's some of the ones that get a little sneaky with you. This one will make you think a little bit. All right, log base 9 of 3. Again, if we think about what it is, it's got to figure out that that's got to equal x. So we're trying to figure out what x equals. So if we rewrite it, it's 9 to the x power equals 3. Okay. So this is the part that makes you go, just a little bit. Because on this one, if it was 3 to the x power equals 9, we know that would be 3 squared, right? So we know x would equal 2. But it's going the other way.
Would be negative?
Close. So what could we do to 9 that would get us 3? What power, what operation? Okay, we can take the square root, right? Which means that if we've got square root, and y'all both kind of all around this one, you're on this one, that if you take the square root of 9, that would equal 3. So here's a good flashback to last chapter. What if it's square root of 9? How could we rewrite that with a what index goes here? We know that's 2, right? So technically that's 9 to the first power, and that. So we could rewrite that as 9 to the 1/2 power. So anytime you've got square root, that's going to equal to the 1/2 power. So in that case, 9 to the 1/2 would equal 3. So in that case, our x value would mean that would be 1/2. There we go. All right, now here's where you're not going to like me very much, because we're going to show you how to use your calculator. Because you're going to be like, why did we do all that if we're going to use our calculators to get the exact same answer in like 10 times less amount of time? Because we're going to show you one other thing where you're going to be able to use it when you're not able to use your calculator. So we're going to show you how that kind of ties together for this one. So, all right, so here's where it comes to your calculator. Actually, let me show you the next one first, then I'll show you how to use your calculator. All right, now here's the big thing that we're going for. So let me show you this one, and then we'll get calculators. This would be one where they would actually ask you to solve, where you've already got the equals equation that's here. So it's similar to what we were doing before, where they just said to simplify without using a calculator. This would be one where they would still tell you to not use a calculator, but you still could maybe need to use a calculator. But anyway, we'll just kind of see what it is here. So you got log of x equals 2. Okay, first off, what base needs to be there?
10.
All right, we got to make it base 10. So very first thing is we're going to rewrite this one so it's log base 10. Okay, and as it is, there's no way you can use a calculator to get this answer based on what's here, and we'll show you that part in a second. So we're going to do like we did before. We're going to rewrite this thing, put it in exponential form. So that makes it 10 to the second power equals x. Can everybody do that math in your head? Because what is 10 squared? There you go. That's 100. And where we're going to tomorrow, with maybe not so much today, but tomorrow, that's where we're kind of going, is that we've got questions that we have that if you have something that's in log form and you're not able to solve it, if you rewrite it in an exponential, then you should be able to solve that problem out from there.
Now I'm getting kind of angry because how am I going to know the difference when put the x equals like 0, how we were doing before, or x equals 100? Like, how would I know when to put the x equals 2?
So basically on those problems, it's probably going to tell you to do this. It's probably just going to tell you to simplify. So if it's already got the x there, you'll put x equals. If you don't have an x, you're just going to put like the number.
Okay.
Yeah, 3 or 0, technically you wouldn't even put the half there. The answer would just be 1/2 if you kind of go through that part. So, okay. Okay, so we've got our properties. We've got condensing back and forth. There's the simplifying part of it. Here's where we're going to actually use your calculator. Okay, and on your calculators, the log button uses base 10. The other one's on your calculator, whether it says LN or LN or LN, they're all the same button. Sometimes it looks different. I know sometimes in Math Excel, you'll see like that with the cursive LN. Sometimes on the buttons it's this, sometimes it's that. It doesn't really matter what it is. It's all the same thing, just written 3 different ways. These are all going to use base E. And if you, I know we talked a little bit about E the other day, yesterday, using the PERT formula. That E's that, it's that button that's on your calculator. That is, it's second, and again, if we hit second and LN, the E is back behind it there, so we get E. If we just do E to the first power, E by itself is like 2.7182818. It's like pi almost. It's one of those numbers that just kind of happens, it occurs. So when we're talking about E, we'll just say it's about 2.718. Now, you don't necessarily have to know what it is. I'm not going to ask you how much is E. I'm not going to ask you that. The main thing is just knowing kind of how to use your calculators on this one. So what you're going to do is it's the change of base formula. And for the change of base formula, basically is this one, is that if you have the log of some number and B is your base, to use your calculator, here's all you have to do. And again, if you've got Casio calculators, some of these that may already have that button built in with it, so you don't even have to do that. Yeah, so if you got the Casios, that's this button right here, so you don't even have to do that. You can just punch it straight in. If you have some of the Texas Instruments, some of the other Casios, they don't have that button, so we'll show you how to do for this thing. That you have to do the log of N divided by the log of B. And again, with both of those, we're going to make them both base 10. And if they're base 10, then you get to use your calculator. So if we can get them so they're both in base 10, we can do that. Now, you can also do this one. You can also use the LN button. You can also do the LN of N divided by the LN of B. So you can either use the log button or you can use the LN button. Which button you use, it doesn't really matter. Just as long as you use the same one twice, it's okay. All right, which means if we go back to this last question we're doing back here, the very first one we did where we were kind of rethinking on this one, that if they give you this problem, this log of 64, base 4, that if they ask you to simplify this one without a calculator, you can actually use your calculator because if it's a multiple choice answer, nobody knows how you got your answer. So if they give you log of 64 base 4 and they tell you to simplify it without a calculator, just use your calculator. So you're going to do the log of 64 and divide it by the log of 4. The only thing you have to do is be careful on these when you're using these calculators is when you do the log of 64. Notice how it's got the parentheses here. you've got to close that parentheses off and then just do divided by the log of 4. So if you've got a number with these calculators, if it automatically puts that parentheses in, just make sure to close it off after you put in the number, and then you hit enter, and it tells you that answer is just a nice plain old 3. Okay. So, and then what the calculator is actually doing is it's going back through this process like we did back here of working this part of it out, but they do all that for you. So then you can just take the number you've got and you punch it in. So just throwing out a different number here. So if we had to do the log of 81 base 3. And sometimes they will actually make you rewrite it when the change of base formula. So they might actually make you put log of 81 divided by log of 3. Sometimes they will, sometimes they won't. So if they do that, you have to kind of put that back in there. Again, if they make you put that, technically that would be base 10 on both of those. But the main thing is, again, that you're going to do log of 81. And just, again, make sure you close off that parentheses so that you stop with that number and then divide it by the log of 3. And your answer is just 4. It's 4. If you don't get 4, make sure to let me know because your calculator, it shouldn't be in the wrong mode. But it should be fine. So even if we go back to the other one that was back here, if it was the log of 463 as the base and 1 was the number. So log of 1, base 463. Again, technically it's the log of 1 by the log of 463. And hopefully this is one of those that, again, if you ever see log of 1, you hopefully get to the point where you don't need your calculator. If we do the log of 1 divided by the log 463, yeah, it's get a nice plain old 0. Okay, and again, whether you use log, you can also do ln of 1 divided by the ln of 463. You will get the exact same answer. So if you do ln of 1, and again, make sure you close it off, divided by the ln of 463, you still get 0. So whether you use the log button, whether you use the ln button, it doesn't really matter. You get the same answer either way if you go through this thing. Question? We could have back there. So technically, yeah, back here, those technically would have been base 10. Okay. But again, if you take some numbers and you don't put anything on here, it's automatically assumed that these are base 10. So you don't necessarily have to put base 10 there if you don't want to. All right, now here's what actually comes in handy for these. And this is where, again, this is kind of where we're going for tomorrow when we start solving these and working with different parts and pieces here. If you've got the log of 5 base 2, that if you were, and again, you don't have to write this part, but if you were thinking about this one, it's 2 to the what power equals 5? We don't know, right? Because it's not, now if that was 4, we're in business. But if that's 5, we don't know what that number is. So that's where having the calculator kind of helps you to understand on this one that now we can just punch that thing straight in. We can do log of 5 divided by log of 2, and that's about 2.3 if we set that up. So that's where that's really going to come in handy when we start solving equations. That if, and again, if this was 2 to the x equals 4, we've got it. But if it's 5, 6, 7, we don't know what that number is, and that's where the calculator is going to come in nice and handy for this thing.